Welcome to the Cisco Network Academy Introduction to Networks course. In this video, we review Module 2, Basic Switch and Device Configuration. This module introduces the initial steps for configuring switches and end devices, including setting up device names, passwords, and IP configuration. We'll also explore how to navigate the Cisco IOS command line interface to perform essential configurations. What is the Cisco IOS and how do we access it? Cisco's InterNetwork operating system is the software that powers Cisco network devices, such as routers and switches. Like any operating system, it manages hardware resources, runs essential network services, and provides an interface for users and administrators to configure and control the device. At the heart of every operating system are two key components, the kernel and the shell. The kernel communicates directly with the device's hardware, handling tasks like memory management and input-output operations. It acts as an abstraction layer, hiding the complexity of the hardware and providing a consistent interface for higher-level software. While it's critical to the system's operation, the kernel itself isn't something users can see or touch. The shell, on the other hand, is what users interact with. It serves as the interface between the user and the kernel, receiving commands from the user and passing them down for execution. Depending on the operating system, the shell can be a graphical user interface, GUI, or a command line interface, CLI. A GUI is visual and intuitive, often found in home devices such as Microsoft Windows. The CLI is entirely text-based and requires typed commands. Though it has a steeper learning curve, the CLI offers precise control and remains the foundational interface for configuring and troubleshooting Cisco devices. Accessing a device's CLI can be done through console, telnet, or SSH. A console connection provides out-of-band access, which means it is a direct physical connection to the device and does not rely on the network bandwidth for connection. This method is especially important for initial setup or troubleshooting when network access is unavailable. In contrast, Telnet and SSH provide in-band access to connect remotely over the network. While Telnet transmits data unencrypted and is considered insecure, SSH encrypts all communication, making it the preferred method for secure remote management. To show Cisco's IOS, I have connected to a Cisco Catalyst 3560 multi-layer switch on my network using Telnet. When you first log into a device, you are placed into user exec mode. This mode is identified by the CLI prompt that ends with the angle bracket symbol. It allows access to only a limited number of basic monitoring commands. To have access to all commands, including device configuration, you need administrative access. Cisco refers to this administrative mode as privileged exec mode. You access this mode using the enable command. Notice the prompt changes to end with a £, indicating privileged exec mode. In this mode, we have access to everything. We can perform all monitoring and troubleshooting commands, such as the show IP interface brief command. To save typing, you can just type the first few letters and hit the tab key. For example, if I type INT and hit the tab key, it will automatically complete the word interface. From privileged exec mode, we can also access device configuration modes. To enter global configuration mode, we use the configure terminal command. You don't need to type the entire command. Typing CONF_T is a shortcut that works as well. Notice how the prompt changes. If I want to change the configuration on an interface, I can move to interface configuration mode with the interface command. If you're ever unsure of available options for a command, type the command followed by a space and then a question mark. This will display a list of all possible interfaces you can configure. Typing INT space F01 is a shortcut for interface Fast Ethernet 01. Notice the prompt changes to config IF, which lets us know we're now in interface configuration. I can return to global configuration mode with the exit command. There are a lot of sub-configuration modes that you will learn about as you go through these courses. Another sub-configuration mode is line configuration mode. This is used to configure access methods, such as telnet or console access. For instance, line VTY04 enters virtual terminal configuration. If I want to exit any sub-configuration and return to privileged exec mode, I would use the end command. Becoming comfortable with the Cisco IOS is an important skill to have, and I recommend practicing either on real-world devices or in a lab environment, such as Cisco Packet Tracer. This is the basic structure of a Cisco IOS command broken down into its key components. The prompt is the starting point of every command line input. In this case, switch indicates the device name and current mode, which is user exec mode. The command is the action you want the device to take, such as show or ping. This is always the first word you type after the prompt. After the space is the additional input needed to complete the command, which is either an argument or keyword. It could be a specific protocol, IP address, interface, or any other parameter that tells the device exactly what to act on. When using the Cisco iOS, understanding command syntax helps you enter commands accurately. The boldface text shows exact keywords or commands you type as is. Italic text represents values you supply, like names or IP addresses. Square brackets indicate optional elements. Braces show required elements. Braces with pipes inside square brackets mean that one choice is required within an optional element. Basic device configuration is the foundation for setting up any network device. It involves assigning meaningful names and securing access with strong passwords to keep your network organized and protected. When naming your devices, follow these rules. The name must start and end with a letter. You can use numbers and dashes in between, but no other special characters are allowed. As a best practice, use all capital letters for device names to keep them consistent and easy to read. Keep names clear, consistent, and meaningful to reflect the device's role. The online course recommends passwords be at least 8 characters long, but a stronger best practice is to use passwords with at least 12 characters for better security. Use a mix of uppercase and lowercase letters, numbers, and special characters. Avoid common words and never use the same password or simple variations of it across all devices to reduce risk if one device is compromised. Now, I want to break away from the course slides for just a couple of minutes. This is the part of the course where you'll begin doing labs using Cisco Packet Tracer. I think it's important that you become familiar with how to use this valuable network simulator. Let's take a tour of Cisco Packet Tracer. If you don't already have Packet Tracer installed, the easiest way to get it is to go to the Cisco Networking Academy website and search for Packet Tracer resources. There you'll find the latest version available for Windows, Mac, or Linux. Installing it ahead of time will allow you to follow along with the labs and experiments as we go. When you first open Packet Tracer, you'll notice the main workspace in the center of the screen. This is where you'll drag and drop devices to build your network topology. Down at the bottom left, you'll see the device type selection box. Here you can choose categories like network devices, connection media, end devices such as PCs or servers, and even IoT devices. Beneath that is the device-specific selection box. Once you pick a category, this is where you'll see the specific models available to the right. For example, if you choose switches, you'll see different Catalyst models that you can drag onto the workspace. Now look down at the lower right-hand corner of the screen. This is where you'll find the controls for real-time and simulation mode. By default, you're in real-time mode, where the network acts as if it's running normally. If you switch to simulation mode, you can slow things down, pause, and even step through packet movement one hop at a time. This is one of the most powerful features of Packet Tracer. Up on the top left, you'll also notice tabs for logical and physical workspaces. Most of the time, you'll work in the logical view to build and configure your networks. The physical view, however, lets you see things like racks, cabling, and even building layouts, a neat way to visualize a more realistic environment. Let's try something simple. I'll drag a 2960 switch onto the workspace, then add 2 PCs. To connect them, I'll click on the Connections tool at the bottom, choose a copper straight-through cable, and connect each PC's Fast Ethernet 0 port to the switch's Fast Ethernet ports. Now, before we can test connectivity, we need to assign IP addresses to the PCs. I'll click on PC 0, go to the Desktop tab, then select IP configuration. For PC 0, I'll enter IP address 192.168.1.10 and subnet mask 255.255.255.0. Then I'll do the same for PC1, giving it IP address 192.168.1.11 and the same subnet mask. Now both PCs are on the same network. To test connectivity, I'll open the command prompt on PC 0 and type ping 192.168.1.11. And when those replies come back from PC 1, congratulations! You've just brought your very first network to life. This simple example shows how Packet Tracer can be used to build a topology, configure devices, and verify connectivity. As we go further into the course, you'll use Packet Tracer not only for PC addressing, but also for switch and router configuration, troubleshooting, and more advanced labs. You'll also have structured labs along the way with pre-built topologies that guide you step by step. But I also want to encourage you to take some time to experiment on your own. Try dragging devices into a blank workspace, building a small network from scratch, and applying what you have just learned and what you will learn along your journey. Exploring Packet Tracer outside of the labs is one of the best ways to reinforce your skills, discover how things really work, and gain the confidence to tackle bigger challenges as we move forward. You've learned some basics about how to navigate the Cisco IOS. Now let's look at saving configurations. A switch stores settings in two files, the startup config, saved in NVRAM and used every time the device reboots, and the running config, which is in RAM and controls the device right now. Keep in mind, RAM is temporary. It clears when the device powers off. To check the current configuration, use the command show running config in privileged exec mode. If a change to the running config doesn't work as expected and you haven't saved it, you can undo it easily. Option 1 is to remove the commands manually. Option 2 is you reboot the device using the reload command in privileged exec mode. This resets the running config back to the saved startup config. Keep in mind, this causes some brief downtime for users, but if the bad changes were already saved, use erase startup config to wipe the saved settings. Then reboot the switch to clear the current configuration from RAM. This gives you a clean slate and restores the device to its default settings. A network device's configuration can also be saved outside the switch. Using a terminal emulator like PuTTY, you can capture the output of the show running config command and save it as a text document. This is useful for keeping backups, sharing configurations with teammates, or restoring settings on another device. Having a saved text file provides an extra layer of security since you won't lose your work if the device fails or needs to be replaced. Let's look at how devices communicate across a network using IP addresses, port numbers, and the media that physically connect them. Devices need an IP address in order to communicate on a network. An IPv4 address is a 32-bit number written in dotted decimal format, like 192.168.1.10. It's paired with a subnet mask to define the network range and a default gateway, which routes traffic out of the local network. IPv6 addresses are 128 bits long and written in hexadecimal. They provide a vastly larger address space and are designed to support the growing number of devices connected to the Internet. Now, let's talk about network media, the wired or wireless connection that links end-user devices to the network. End-user devices rely on media like Ethernet cables, fiber optics, and Wi-Fi to send and receive data. Each type of media has its own benefits and limitations. For example, Copper Ethernet is reliable and cost-effective over short distances. Fiber offers high speed and long-distance performance, and Wi-Fi provides flexibility but can be affected by interference and range. Configuring IP addresses is one of the most essential tasks a network technician performs. It allows devices to communicate reliably across a local network or the Internet. Let's start with static IP configuration. In a static setup, an IP address, subnet mask, and default gateway are manually entered on the device. This gives full control over addressing and is typically used for devices like servers, printers, and network infrastructure that require consistent, unchanging IP settings. Next, we have dynamic IP assignment, which is handled by a DHCP server. When a device connects to the network, it automatically receives an IP address and other configuration details. This is the most common setup for end-user devices, including desktops, laptops, and tablets. It simplifies management, reduces configuration errors, and supports large networks efficiently. Let's return to Packet Tracer. We will work on Packet Tracer Lab 2.7.6, which tasks us with implementing basic connectivity. We'll configure 2 switches and 2 PCs, assign IP addresses, and verify connectivity across the network. Before we begin, here's a quick tip. In Packet Tracer, you can dock the instructions on the left side of the window by selecting this checkbox. This makes it easier to follow the steps while you work in the workspace on the right. Some labs ask you to connect a console cable between a workstation and a switch for initial device configuration. When the instructions say to do that, click Connections, then select the console cable. In this particular lab, they are not asking us to do that, so we can simply click the device we want to configure. In this case, we'll begin with switch 1. Type Enable to go into Privileged Exec mode, then Configure Terminal to enter global configuration. First, we'll give it a host name, which is defined in the addressing table. Then we set the console and enable passwords for secure access. You should always use the Enable Secret command to encrypt the privileged exec password. We'll also configure a Message of the Day banner to warn unauthorized users not to attempt to log in. Save the configuration to NVRAM. With the basic settings in place, we'll move on to the management interface. Here we assign switch 1 an IP address from the addressing table and bring the interface up using the no shutdown command so it becomes active. To confirm, we'll check the interface status to make sure the IP address is applied correctly and that the interface is operational. Once switch 1 is complete, we continue with switch 2. The process is the same with different hostname and IP settings. Protect console access in privileged exec mode. Create a banner message of the day. And save the configuration to NVRAM. Next, we configure the management interface using switch 2's assigned IP address and enable the interface. Again, we verify the configuration by checking the interface status, ensuring it shows the correct IP address and that the interface is active. With both switches configured, we now turn to the PCs. On PC 1, we go to the desktop settings and select IP configuration. Assign the IP address and subnet mask shown in the addressing table. We repeat the same process for PC 2, entering its assigned IP address and subnet mask. Once the PCs are configured, we are ready to test connectivity. From PC 1, we open the command prompt and ping PC 2, then switch 1, and finally switch 2. Each ping should succeed. If the first one times out, try again, as sometimes the initial ping fails while the devices update their MAC address tables. Successful replies confirm that connectivity is established across the entire network. You can see how well you did by looking at the completion percentage at the bottom. 100% is ideal, and you can examine what you missed by clicking the Check Results button on the bottom left. Select the Assessment tab and see what is missing or incorrect, indicated by the red X marks. I already know that I skipped saving the configuration on the S2 switch, but I also incorrectly configured the privileged exec password. And in reviewing the instructions, I can see I should have used class as the enable secret password. I'm just going to pretend I did that, on purpose. In this lab, we fully configured 2 Cisco switches, including setting up switch virtual interfaces on each for management access, and set up 2 PCs with IP addressing and verified communication between all devices. I highly recommend completing all labs in the course. They are a great way to become familiar with the configuration commands you will need in your network career journey. As we wrap up Module 2 of Introduction to Networks, let's take a moment to reflect on what we've covered and why it matters. In this module, we covered the fundamental building blocks of network configuration. We started with basic device setup, including assigning device names and creating secure passwords to protect network access. Next, we explored ports and addressing, learning the structure of IPv4 and IPv6 addresses and how different network media connect devices, each with its own benefits and limitations affecting network performance. We then focused on IP addressing configuration, understanding how to assign IP addresses both statically and dynamically using DHCP and how these settings apply to real devices. Hands-on labs and Packet Tracer helped reinforce these concepts, from verifying switch configurations and securing access with passwords to configuring IP addresses on switches. Importantly, we also connected to a real switch using PuTTY, gaining practical experience with accessing and managing network devices through the command line interface. By mastering these fundamentals, you're well prepared for more advanced networking tasks ahead. So, what's next? In Module 3, we'll dive into protocols and models, the essential rules and frameworks that make network communication possible. We'll explore the OSI and TCP/IP models, learning how each layer functions and interacts to ensure data is sent, received, and understood across diverse devices. And networks. We'll break down key protocols within these models, showing how they govern everything from addressing and routing to error handling and application services. Understanding these protocols and models is critical for diagnosing network issues and designing efficient, reliable networks. Get ready to uncover the structure behind all network communication and see how protocols work together to keep data flowing smoothly. Make sure you click that subscribe button, and let's keep building your networking knowledge one step at a time.